I just want to highlight how you can run Ensemble models on the EcoCommons platform. So on the dashboard tools that we have, how would we run an Ensemble model? And as with many of our dashboard tools, this is fairly easy to do. And generally for an Ensemble model, you don't have to think too much about what you're doing because the thinking that you did was before the Ensemble step, hopefully. So Ensemble's fairly simple. So if you wanted to run an Ensemble model, you'd give it a name, test, for example. And then we're going to pick source experiments. So currently, what you're doing is you're taking the outputs, so the predictions from previous experiments, either species distribution model experiments or climate change experiments. So some of your climate projections, you might want to average those. That's common in Ensemble modeling for climate projections. It's also becoming increasingly important for species distribution modeling. So in SDMs, there's a recent paper out in Nature not too long ago that talks about how often results of SDMs, if you run multiple SDMs and then take an average of the outputs, Ensemble results from the outputs, you get a better model output than if you just rely on one model. If you really know that model well, right, and you can tune it and calibrate it and validate it, that one model you know well is probably going to outperform anything else you're going to do. But if you don't know each of those algorithms particularly well, and you want to try and come up with a result fairly quickly, you can run just a bunch of species distribution models and then choose the ones. So here we're choosing a bunch of species distribution models that were run. So boosted regression tree, bioclim, surface range envelope, maxent, random forest, GLM. So we're going to go ahead and use all of those that were run in our previous experiment. And we're going to average them. So again, when we look at what those models look like, so these are all my results. These are the SDMs that I ran, the sort of the base layers. So we're taking all of these results, right? So if we take, and this was for the mouse-eared hawkweed, but these results that, are including boosted regression trees, they're including these output maps, but they have all that other stuff, all that other output. So that's mouse-ear hawkweed distribution in Australia and, other places as well in this particular model. But we're going to average all of those results. And when we do that, when we hit run, I think this is the result that we get. So the most common thing to do is to just report the mean result, right? So this is, on average, these are the areas with a suitable climatic niche for mouse-eared hawkweed, given all the other models that we ran. And actually that result doesn't look too bad. But then you can summarize these probabilities. Well, what's the, if you want to understand the range of those predictions, well, there was one model that indicates that there's hardly any mouse-eared hawkweed suitable in Australia, maybe a couple places in Tassie. And there was one model that predicted, well, you could put mouse-eared hawkweed in a lot of places, right? The average is usually what you'll report. You can also get a map of the variance in those predictions between whatever models you chose to put in this average. So there's a lot of variance in some of these areas between models. And you can break up your results into percentiles as well. And as usual, you can download and look at the R script. In the case of Ensemble, it should be fairly simple, right? All we're doing is we're taking our model object and we're predicting it to that future raster stack of environmental predictors inclusive of, not future environmental predictors, but we're just taking a raster stack of all of the outputs from our species distribution results. Sorry, I was thinking climate change there for a second. So for BRT, I'm going to take that result, that mapped prediction, stack it on top of my Maxent mapped prediction, and take the average. Right, so that's kind of what's happening. So again, Ensemble's fairly simple. It's fairly quick to run, fairly powerful oftentimes. If you haven't spent hours and hours fine-tuning a Maxent model or a BRT model, an Ensemble model might not be a bad way to go. And again, lots of support material on how to do this. I think our Ensemble support material will have a link to that Nature article that highlights that sometimes Ensemble models perform quite well. And there's more learn and support material. You know, we've got code that you can look at. You've got videos on all these different workflows. There's theoretical information about the theory of what we do at EcoCommons. So all kinds of stuff that you can find. You can contact us directly. And again, I always like to flag that if you feel like this isn't enough information in your R script, you know, you can say, oh, well, give us some feedback. Put your email in there and submit it, and it will come straight to us. And we will, you know, we're in the service of giving you what you want. So feedback is what we need to do that. So thank you for tuning into this video, and might see you at the next one.